Good morning, everybody. Today we have to discussing about the electrochemistry, and in this topic we have to discussing the for second semester diploma students discussing about the standard hydrogen electrode or normal hydrogen electrode. In the previous class we have to discuss about the what is the electrode potential, what is the standard electrode potential, what is the electrode, what is the standard electrode. So in this session we have to discuss about the standard hydrogen. One of the example is standard hydrogen electrode. How can we have to construct the standard hydrogen electrode, and how can we calculate the standard potential, measurement of the standard electrode potential. What is the standard electrode potential of hydrogen? What is the functioning? So here the hydrogen standard hydrogen electrode contains 1 molar hydrochloric acid HCl in a vessel in which platinum plate is partially act as a conductor dipped and act as a conductor. Hydrogen gas in 1 atmospheric pressure bubbled into the solution at 25 degrees Celsius. So in which cell, in hydrogen cell, we have to maintain the solution concentration 1 molar and room temperature is 25 degrees Celsius, and hydrogen gas at 1 atmospheric pressure. When we have to maintain, by maintaining these conditions, when we are takes the potential, that potential or that electrode is called as standard potentials or standard electrode. So here we are called the standard hydrogen potential, standard hydrogen electrode. The potential of normal hydrogen electrode is arbitrarily taken as zero. Arbitrarily taken as zero. It is a universally zero. This electrode is represented as a platinum, H2 in the bracket 1 atmospheric pressure. H2 is a gas. That's why you have to maintain the in the bracket 1 atmospheric pressure oblique H plus. Why? Because it will be giving the H plus ions. That is the electrode, representation of electrode, and you have to take hydrogen. Look here the diagram. This is the, you have to take in the one of the container. In that container you have to take the HCl solution, and this is the platinum plate, and we have to take in a inverted tube to bubble the hydrogen gas into the solution, and we have to take in one of the wire. This is the construction of standard hydrogen electrode. It is a single electrode. Its electrode potential we have to taken as a 0. So it not possible to determine experimentally the potential of a single electrode. Actually, electrode potential is not possible to determine the single electrode. We can only measure the potential difference between two electrodes potentiometric alloy in order to determine the electrode potential. So, normal hydrogen electrode is taken as a primary reference electrode. Primary reference electrode. The electrode is coupled with a standard hydrogen electrode through a salt pitch. The voltmeter reading directly gives the standard electrode potential of the electrode. Since the potential of standard hydrogen electrode is 0. 0. According to the modern convenience of IUPAC, the electrode potential is given a positive sign if electrode reaction is reduction. Electrode reaction is reduction when connected to the standard hydrogen electrode. The negative sign is given if electrode reaction is oxidation when connected to standard hydrogen electrode. The arrangements of the electrodes in the increasing order of their standard reduction potentials is called the electrochemical series. So, your standard hydrogen electrode was constructed as like that, whatever it is given in the diagram, and we have to measure the electrode potential of standard hydrogen electrode potential is 0. Why it's called as standard means nothing but when we have to maintain the 1 molar concentration and 1 atmospheric pressure 25 degrees Celsius. When these three conditions we are applied to a solution to measure the potential, then it is called as standard hydrogen electrode potential. So now, what is the electrochemical series? Electrochemical series and its significances. Electrochemical series. The arrangements of electrodes in the increasing order of their standard reduction potentials is called electrochemical series. In this series, the topmost electrode is lithium and bottom of the electrode is fluorine. What is the electrochemical series? The arrangement of the electrodes in the increasing order of their standard reduction potentials is called as electrochemical series. In this series, the topmost electrode is lithium and bottom of the electrode is fluorine. And significances of electrochemical series. The metal which is higher in electrochemical series act as reducing agent or anode and undergoes corrosion first. The metal above the hydrogen are called the active metals, which can displace hydrogen from dilute acids or water. Example: zinc plus 2HCl gives to zinc chloride plus H2 gas. So, the metal below hydrogen are less reactive. They do not liberate the hydrogen gas from the dilute acids and water. The metal with the higher negative potential displaces a metal with lower negative potential or positive potential, that is the all metals below its in the series from the salt solution or the metal. Example: zinc displaces the all metals underneath it in the electrochemical series. So, significances of electrochemical series: zinc plus cadmium sulfate is to zinc sulfate. Zinc sulfate and cadmium. The reactivity or the reducing character decreases from top to bottom of electrochemical series. So lithium is the strongest reducing agent and fluorine is the strongest oxidizing agent. So now we have to observe the standard electrodes and their standard electrode potentials. Suppose lithium, you have to take lithium minus 3.045 and top one most, and its electrode is represented as a lithium plus oblique lithium, and its electrode reaction is lithium plus 1 electron goes to lithium, and potassium electrode reaction is electrode is represented as the K plus oblique K, and its reduction potential is minus 2.925 and K plus 1 electron is to K, and calcium plus 2 plus oblique calcium minus 2.870 calcium plus 2 electrons is to calcium. So next one, sodium electrode, zinc electrode, iron electrode, cadmium electrode, cobalt electrode, nickel electrode, stannous electrode, lead electrode. Whatever it may be, we have to observe the electrode potentials gradually increase, and its reactions will be represented as the gaining capacity of electrons is called as the reduction reaction. It should be the potential is called as reduction potential. So copper plus 2 plus gives to copper, and these are the all positive potential is there, and here also gaining capacity is there, but positive is there, and then very less gaining capacity is there. That's why slowly decreased. So that's why last one we have to take the. So in this session, important questions questioning what is the standard hydrogen electrode or normal hydrogen electrode. When we have to measure the hydrogen electrode potential has a zero by using the 1 molar concentration HCl and at room temperature 25 degrees Celsius and hydrogen gas at 1 atmosphere pressure, then that electrode potential is called as standard hydrogen electrode potential or standard hydrogen electrode. Very simple. And electrochemical series, very important question. Define the electrochemical series and write its significances. Okay. Electrochemical series. The arrangement of the electrodes in the increasing order of their standard reduction potentials is called electrochemical series. And significances are very simple. In this electrochemical series, topmost element electrode and bottom of the electrode. Topmost electrode is lithium. Bottom of the electrode is thorium. The metal which is higher in electrochemical series act as a reducing agent or anode or undergoing the corrosion casting. The metal above the hydrogen are called the active metals which can be displace hydrogen from derived acids or water. For example, zinc plus 2HCl gives to zinc Zn Cl2 plus H2. The metal below hydrogen are less reactive. They do not liberate H2 from dilute acids and water. The metal which higher negative potential displaces a metal with lower negative potential or positive potential. That means all metals below its in the series from the salt solution of the metal. Okay. In further classes, we have to discuss about the electromotive force and its calculation and numerical problems are EMF, electromotive force. Okay, thank you everyone.